Hello, everybody. How are we all doing today? My name is Mark Mandel. I am a developer advocate for Google Cloud Platform, specializing in games, working today on the Agones project, which is a project for building game servers, well, actually for hosting and scaling game servers on top of another open source project called Kubernetes. I've got this new fancy microphone all hooked up here, so I think this side's going to work well. We'll see how we go. Let me know if my head view tilting, like if I look over here so I can see the chat room, if that becomes a problem or anything like that. But hopefully everything goes relatively smoothing. It's also real fancy, and I feel fancy using it. I've also got my cup of tea, very important. It's a Crayola mug. Well, you can't see it if I point it that way. That's better. And that's very important too. So, all right, cool. So, what are we working on today? Let's throw some code. There we go. Let's go to screencast. Excellent. So, what are we doing? We're working on this thing called fleets. So actually, to explain this, why don't we actually show you? So up the top here, I've got just a shell, so I can actually see what's happening inside my Kubernetes clusters, and I shouldn't have anything. But I have the latest version of Kubernetes installed. So Kubernetes, where we get pods, namespace Agones, so that's in there. We actually have a look. We've got this installed with Helm, which is another package manager, which is there too. All right, cool. All right, a couple of people said hello. Sweet, awesome, nice to see you, Mr. Squarepeg and Mr. Pardesho, or Mr. or Mrs. I should say. That was very rude of me. Where was I? Yes. So I have Agones installed. What I'm going to do is set up a fleet. So a fleet is a set of warm game servers. So if I have these an example, simple UDP server fleet. Here we go. It's really just a configuration of a set of Docker containers, but they're specific for being a game server. And we've got some SDKs and other fun stuff like that. But what we're going to do is just create this fleet of simple UDP, which is just a little game server that basically just sends and receives UDP packets that we can echo backwards and forwards, essentially. So let's see if we've example where we simple UDP server fleet.yaml. So we'll apply that. So what we should see is if we have a look at our game servers, we should have 2 of them, and we don't. I've broken something already. Oh my god, that's really impressive. That's not there. Oh wow, I really did break stuff. All right, so this was the first time I've actually run this code on a cluster. So let's see what I've broken. This should be hilarious. Will Agones work with Nakama? What does Nakama exactly do? So Agones is specifically for running dedicated game servers at scale. Assuming you need direct connections, say over UDP or TCP with something like Nakama. In theory, you could host it on there. I don't know exactly enough about Nakama to say yes or no authoritatively, but get logs. What do I want? So let's have, actually, no, let's describe our fleet. And it created a game server. Oh, I did something very strange. Oh, interesting. Okay, so the new thing that I've done here is I've done this thing called a rolling update. Which is basically, I've given it rolling update. So when a fleet is meant to transfer from one type of game server to another, it's meant to do it in a rolling fashion. Now, what it looks like I've done is I've actually broken the system that sets up the game server set, which is basically it's basically a set of game servers behind the scenes. That's all it is, and it controls how many are currently running. Yeah, so Nakama is a distributed game server, but what does that mean? Because I know it does a bunch of different things, and we could probably dig into that. But yeah, when it says distributed game server, what does that mean? So when I talk about game servers here, I'm talking about, say, full dedicated simulations of like FPS games or MMO games, those types of things. I don't think Nakama sits in that space. Like I said, I'm not 100% sure. I do know some of the people from Heroic Labs quite well, but I would have to ask them directly. But it's a good question, and we could potentially look at it. It would be kind of interesting to see. All All right, let's see what I broke. So this is fun. I didn't think I broke anything, but I think that I have. So let's have a look to see. So we talked about it previously. A fleet creates a game server set, and then when you're in a game server set, then creates a bunch of game servers, like this set of game servers that it's running. And then when you want to do a update of what's happening, it creates a second game server set, and then basically rotates through to get to the other side. That's basically what should happen. But looks like I broke stuff. So GS set is just shorthand. So I do get a game server set. That is correct. If I describe the game server set, I think I know what the bug is. And I did it. Okay, so this is currently created, but the replicas are 0. I am silly. I am very silly. All right, this is interesting. I can tell you where the code problem is. So let's have a look. This is interesting. Oh, and I think I know. Ooh. I know where this is. Okay. This is fun. Okay, so here, we have this thing inside Kubernetes that you write, this thing called a controller that manages resources. And basically what it does is it synchronizes the state of whatever we think it should be to what it actually should be, depending on what's happening around it and the configuration and stuff like that. Mr. Squarepig is asking me interesting questions. What are these questions? I'm just trying to find out what to use for my game server. So Mr. Squarepig, what do you mean by game server? And unfortunately, game server is one of those horribly and just terribly overused terms that can mean like 17 different things to 17 different people. So I refer to dedicated game servers as simulation servers quite a lot. Generally, so like, and you say you require high concurrency for your project. Are you doing a real-time FPS? Are you doing some sort of MMO? Are you doing some sort of MOBA? Is that the type of game that you're building? I'm trying to give my dog a treat so she'll stop wandering around and making noise. There we go. So that's a good question. So if it's that type of game, something like this would be good. I don't know whether Nakama is good for that. I would have to try it. I've never actually tried it. I don't know. Worth having a look. Basically, generally, this is for anything that sends UDP streams. In theory, though, it's anything that wants to maintain in-memory state about what's happening inside your game. So it doesn't actually have to be UDP streams. You could do something, say, over WebSockets with like Node or any other language that does WebSockets. And this would work for that too. It's really very much sort of for that workload that is where stuff runs in simulation inside in memory. So I know what my bug is, though. Here we go. So where are we? Here we go. It's right here. So actually what's interesting is that... All right, I'll talk this through because this is an interesting one. So here in my sync, I grab, telling to sync the fleet. So it comes through, it grabs the fleet in question. I grab all the game server sets that this fleet is owned by. Now, in this particular instance, there should only be one. Oh, sorry, there should be 0. There should be 0 at all. There should be 0 because this is brand new, right? We haven't created anything yet. And so we're going to take the list and we're going to push out 2 things from this, which actually is one that's active. Active is the one that has the current configuration of the fleet. And the rest is everything else that's currently old and should get scaled down. Now, right now, both of these should be nil, and that should be an empty list. If active equals nil, we create a new game server set. When we create the initial game server set, it has a replica set it has a count of 0. That's the way we implemented it this time, at least. And that's something we're going to need to test. So I'm just going to put to do here. Test this in some way. Or test the right replica count comes out of this. Yeah, something, whatever that actually means. But there's, all right, so that comes out and it's 0. It's going to have a replica set of 0 because that's, I'll actually show you. So in here, create game server set, and we just copy in the template. So by default, it has a set of replicas in it, and it's going to be 0. And then we apply a deployment strategy. So here we have a rolling update and a recreate. Actually, with a recreate, it's probably going to have exactly the same problem. Yeah, because it assumes... yeah, I broke stuff. Ooh, and I don't have tests for either of that. Okay, that's cool. Apply deployment strategy. We come through to rolling update. So, and then rolling update is a whole bunch of complicated stuff so that we can add percentages, and it's just getting messy and it's fine. I am making a project similar to Escape from Tarkov, except 2D shooter. So, Mr. Squarepeg, the question you have for yourself is, what is the lowest level of latency that is okay for your game? And depending on that, that will determine what kind of communication protocol you need, and also what platform you could use. I don't know Escape from Tarkov very well, so there's some fun questions in there. So this may work, it may not work. It depends on how you want to build it. There's lots of interesting, fun stuff in here. In theory, this should work for that. I don't know enough about Nakoma, though, to say yes or no, unfortunately. Okay. So the interesting question is, why did that not at least slowly grow this? Which is not really what I want when it's first created. It should just come straight up. But maybe there's a bug. So let's have a look at the log, see if anything shows up there. I have some other ideas. Stuff did break, so that's fun. Okay. Couldn't find active game server set. Creative one. Beautiful. That's what we want to see. I hate it how it does that. Cool. Running webhook. Blah blah blah. Don't care. Okay, definitely something broken. All right. Let's think this through for a sec. I just want to think this through for a sec. This is tricky. Okay, so the answer, I think, to my problem is really that, and we'll need to test this, but if len rest, basically if this is empty, then active.spec.replicas should equal yeah, I think this is should equal fleet.spec.replicas. Basically, so if there's no other game server sets, make sure that it's big automatically. So there's that. And the other thing that I will need to do actually inside replace, recreate deployment, perfect. And that should give me back replicas. Oh, that already does that. That should already do the work. Okay, cool. That should already do the work of what we need to do. Actually, hold on a sec. Bear with me one sec. No, that's right. Or if we come into rolling update. Yeah, that's fine. That's fine. That's fine. This is handling the new case. Okay, let's see if that passes tests just real quick. And see whether I broke anything in the tests and then adjust accordingly. Though this goes to show that there must be something not in my tests that where are we? That I'm not covering. And everything passes. Okay, that's good. Where are we? Also, wait, where was I? Okay, let's build this. That's going to take a little while in the background. While that's going on, I'll have a look at the chat room because there were some fun questions over there. The game would require some sort of persistence layer, mainly for item storage. Yeah, so if you need something like that, maybe Nakama or half a dozen other databases or anything else could potentially work. It really depends on what kind of game you're building. It's basically what it kind of boils down to. So, yeah, interesting question. It's always fun trying to work out exactly what is the technical solution that's going to work for your particular game. It really boils down to, yeah, latency requirements for communications, what data you need to persist and how often you need to persist it, that kind of stuff. So there's lots of fun stuff in there. There's layers. There's layers to these things. Okay. So this is building in the background. Cool. It takes a couple of seconds. My dog is now up and awake. Of course she is. She's come to bug me. Oh, I just realized something. I knew that was weird. I was like, why am I getting this strange angle on my screen? So, and that's because I'm not using I'm clicking the wrong thing. I'm not using my nice webcam. There we go. That's better. Whee! Oh, just editing stuff live. It's fine. There we go. Make that a little smaller. Whee! That's nicer. There we go. Isn't that nice? I'll just edit my stream live. It's fine. It's fine. It's fine. It's fine. Cool. Oh, actually, we'll make that a smidge smaller. Whoopsie. Don't move that. There we go. Cool. It's fine. I just edit my stream live. Cool. All right. So while that was being distracting, that's still building. We'll get there in a minute, and we'll see whether that fixes my problems. Actually, while we're doing that, I want to delete the fleet. Let's get rid of that that fleet. In the meantime, while that's going on, looks like that's okay. Cool. That's pushing up. Here we go. She's a bull mastiff cross with we have no idea is basically what it boils down to. She's a rescue. She's lovely. But she's also very noisy. Okay. Let's just do a quick eyeball over... Whoops. Agones control that we just pushed up. Looks like everything is working. All right. I think. Oh, you know what? I always do this. All right, so kubectl delete namespace Agones pod. Just restart that. We'll just restart that, and then kubectl get pods namespace. Basically, what I'd done just then was part of the build system I have for development is if I commit the code, then it'll change the image on the Docker image, the tag on the Docker image. But I didn't do that, so I just need to manually kill it. So let's just make sure so that it would grab the new version that's there. Okay, nothing's breaking. Everything looks pretty happy. All right, let's create a fleet and see what happens. I can just do apply actually. There we go. All right, boom. Let's look and see if we have game servers. Yay, game servers. All right, cool. Cool. We have some stuff. All right, first step. We fixed one problem. Let's see. We got pods. I just want to have a look. All right, so kubectl describe game. Just give me all the game servers. Sweet. So it's ready. Beautiful. And we have some details. If you haven't seen this before, it's just details of a game server. We get an address. We get this kind of stuff. If we describe our fleet, we should see that we have 2 ready replicas. Excellent. This is good. All right, so we'll start with the simplest solution. We'll go from one to the other. If we say kubectl edit fleet simple UDP. Okay. So the easy thing that I have found, well, actually, I'll tell you what we're actually going to do is we're going to bump up the number of replicas. I think 5 should be totally fine. This is a really small number. All right, so kubectl get GS is just shorthand for game servers. And the other fun trick that we have, I describe and then I grep state. I can't wait until the new stuff comes down in the pipe for being able to add your own status values in kubectl for custom resource definitions, so we can have that drop right in. That would be lovely. Okay, so we have 5 of them. They're ready. The thing that I like to change, which is really easy. Normally, you'd be changing this by giving giving a new image, for example, or adding a new image, or doing all sorts of fun stuff like that. I'm just going to change some of the configuration because it's going to give us still a thing that we can float, that we'll see roll through. It'll break some stuff, which is fine, but it gives us a value that we can like grep for and do fun stuff with, so we can see what's actually happening. So let's see. So that's this kind. What I'm going to do is basically change this container port value. If we have a look in our fleet, that's this here. Usually you'd probably actually be changing, like maybe you'd have a new version of your game server or something like that. I'm not going to bother. This is the easy way of testing this by hand. All right, so kubectl, edit, fleet, simple UDP. All right. So let's make this say 6,000. That's a nice difference. I'm kind of terrified. Okay. Well, let's see if we've got. All right, we've got 2 game server sets. Nice. Container port. We have 1. All right. so something has happened. Okay, so we have 2 pods that are terminating. 1, 2, 3, 4. Why is it terminating? That's interesting. Okay, okay, so we're back to 5. Let's have a look. Ooh, I think this is working. It's like slowly working its way through and then doing it sort of part at a time as one deletes. Oh my god, I think this is working. Woo. Is there a plan to do a GUI? Yeah, so eventually, definitely, we want some visualizations for this stuff. It's still very early in its development, still sort of 0.1. We're looking at doing 0.2 very shortly, and then hopefully doing regular releases from then on out. But this is slowly working, so this is cool. 1, 2, 3, 4, 5. We're meant to have 5. All right, let's have a look at our logs. Logs, namespace, Agones, Jelly's controller. I'm just having a look to see if anything's come through. Cool, I didn't see anything bad there. All right, so I just dumped both of these. They should have oh, I think actually we just shut down the last one. I wanted to see it. We created a game server, created a game server, created a game server. That's pretty neat. That's what we wanted. Oh my god, it actually worked. Oh my god, it actually worked. All right, let's try some. We got some other fun things that we need to test though. We got some other fun things that we need to do in here. And I want to have a quick look as well. So what we're going to do is we're going to do that again. We're just going to change it to a different value. Actually, that's pretty awesome, though. That looks like that's doing what it's meant to be doing. I'm just digging through the logs. This is all just JSON logs. I'm just looking to see if, just doing an eyeball to see if any errors happened. And it looks like no. So that's pretty cool. Oh, I'm actually quite excited. All right. Next along the list. Yeah, so let's do that again. I want to look at one thing, which is so a couple of interesting things. If you haven't, like, so in a rolling update, we have some variable sets. So max surge, like how much can you go over the capacity that you currently have, but also max unavailable. So how much can you what's the word I'm looking for? Like how much you're trying to delete every time around. And they're both configurable. They're exactly the same configuration as if you've used a Kubernetes deployment. We also have recreate as also that too, where it just blows everything away and creates it again. All right. So what I wanted to do was make this 7,000. And the reason I wanted to do this is actually get GS set, which is game server set. So I want to actually see what we've got going on here. So this is the new one. It says ready replicas 0, replicas 1, beautiful, right? There's that there. And then where's the other one? Here we go. Ready replicas. Oh, I see. So we are asking to. Oh no, we created. I haven't deleted any yet, so we're just. Okay, pods. We have some terminating. Okay. So actually what I want to see is if I describe my fleet. I'm just having a look at the events. Oh, here we go. So this is the bits that I wanted. Scaling active game server set. Okay, so that's actually moving that up, which is nice, from 2 to 3. I need to put some extra events in here so we can actually see in here the stuff that's happening to the fleet. But you can see the previous one. There's scaling, the active one. We deleted the inactive one. We'll want to have some events in here about what's happening to the inactive game server set and how that's getting scaled. but this is pretty cool too. Could Agones be used to manage a render farm? I have no idea about render farms, so maybe. I give it a definite maybe. Probably not the workload this is built for. I mean, you could use Kubernetes for it, I would say, as a whole. Like, you could use that whole platform. There's definitely would be ways to do that. Probably stateful sets would work. Well, it's strictly for game servers. It's built for game servers. So the whole point, and we'll have a look at this in a sec, actually. In that, where are we? I need watch in here as a command. So, what am I looking for? The thing that it does that's so important for game servers, and there's going to be a whole bunch more coming, is that it's aware of the state of the game server. So once a game server has players in it, essentially it's been allocated from a fleet, which we'll look at in just a sec because that's a thing we need to care about. It needs to make sure that doesn't accidentally get deleted. You can't just shut down game players, right? You can't just turn off a game. That would be bad. So that's like the really important bit. And then there's a bunch of SDK stuff and all sorts of stuff that goes on as well. So if you want to do render farms, there's no reason why you couldn't do that inside Kubernetes. In fact, you probably could do stuff with like the jobs API or something like that. But this looks like it's working. Okay, so my next magic trick, we were just talking about it, is that if allocations happen, they should be left alone. So even if you're rotating from one to the other, it needs to be done such that those older game servers that are still running and have been allocated to players no longer, like, don't die. Like, you can't kill them. So just so you're aware, so to allocate, it's exactly the same as creating anything else. There's a custom resource definition called fleet allocation. So let's create one of those, and kubectl create -f. And it'll give us back the details of what's been allocated. So simple UDP, server, fleet, allocation.yaml, and then I'll actually just punch out the value. So for those not familiar, like all the stuff I'm doing with kubectl, I could do with an API. And in fact, probably allocations you would probably do through an API coming from your matchmaker. So cool. All right. So then I have an allocated game server. Sweet. Which is good. That's all working. I'm gonna create two of them. So we have two of them. So actually, if I say kubectl describe game servers, grepping the state out of them, I can see I have two allocated and I have three ready. I have no idea about UE4 network building support. I don't know anything about rendering. I'm a completely back-end server people. All right. So so we have two allocated. So let's edit this again, and it should do a rolling update, which is great. But what should happen is we should still have those two old ones left behind. They should stay there, but we shouldn't get extra game servers as well. We should still have only 5 once we're pretty much done. So let's have a look-see. So what am I thinking? I'm going to kubectl edit. That's what I'm doing. Fleet, simple UDP. And right now, yeah, so here we go. Replicas, we'll drop that down to, say, 4,000 for argument's sake. Yep. So let's just, all right, so kubectl get pods. Let's just have a look. So we have 2 terminating. Cool. kubectl get GS sets. We should have 2 of them. That's perfect. Grep. Let's have a look. Describe. GS set. Grep. Container port. That's wrong. Hold on, that's weird. Oh, sorry, my fault. I was doing game server sets. I want game servers. Easy thing to make. Okay, so they're still all 7,000. Ooh, something weird has happened. So, we have a bug. We have a bug. What it looks like has happened is that it's scaling down the scaling down the original game server set, but it's not scaling up the other one. That's not good. Okay, we found a bug. All right, so the first bit worked, but the second bit not so much. So let's have a look at our game server sets. Or actually, let's have a look at our fleet, see if there's anything scaling a active game server set from 3 to 4. All right. Oh, so we created the new one. No, that's the new thing that we did. That's interesting. That happened a bunch. Just having a look at that. So that actually, so combined from similar events means that something happens like a lot, and so it just repeats it. So that's interesting. I wonder why that would be happening, but that's a whole other thing. That's a minor other thing. All right, so CL describe all our game server sets. Okay, so this is the old one. It still has 2 allocated replicas in it, so we're just keeping those there, and that's fine. We'll never delete those while they're allocated. That would be bad. Then we have the new one. Where's the new one? Where's the new one? Let's have a look. What's the new one? That's the new one. Let's grab that. That's easier. All right. Oops. Just set. Game server set. Okay, so it's set to, it's got 0 replicas and it has been set to 0 replicas, so that don't work. Okay, well, I tell you what we can do, where are we? What am I doing? 3, thank you. I don't know, my brain's not working today. All right, so I'm gonna commit this actually, because that'll make me feel better. Okay, commit. Fixed initial issue with creating the new game server set. No, there we go. So that makes me feel better. So then I got to go back out of this. I probably need to write some tests for that, but interesting. So I have a test set up. I actually have not this one. I have a test that tests this whole thing. Where are we? Rolling update. Where I can specify scenarios and then see what is supposed to happen. So let's just write a new scenario. This didn't work in tests, and we'll step through. If you haven't seen table-driven development, table-driven testing, at least in Go, this is just that. So basically, we have a data structure with a bunch of values and then expected values after the fact. And then we rerun the thing, just slotting in those values. Cool. Mr. Squarepig, no, don't worry about it. Happy to have the questions. Always good to have a good conversation. All right. So let's grab one of these now. There we go. That'll do. Let's see what happens. So let's see if we can remember what we're having. So in the active one, we have 0 and 0. So it should be happening, actually. Inactive is 5. So basically it's saying, okay, so the active one, so that says the current configuration. So we've created a new one. It currently is set to 0 replicas. It currently actually has 0 replicas in its status, so that's its actual value. Spec for our inactive one will be 5. Our inactive replicas will actually be 5. Allocated will be 2. So, the only other thing, yeah, I really want 25 and 25. That's all right. I think we'll work with what we have. Let me pull up a calculator. Where are we? 30% of 5. 0.3 times 5 is 1.5. 5 minus that. I'm trying to remember if this scales up or scales down. I think it scales up, so we'll go to 4. It'll be right or it's wrong. 25% of 5 is 1. No, 1 and a bit. So it should be 2 coming up. I think that rounds. No, it rounds down on the scale up, and yeah. So from memory, when it does this, it's rounding up on the scale down and rounding down on the scale up. So be aggressive on the scale down and less aggressive on the scale up. Okay, let's run this as a test. Actually, and what I've also got, here we go. Test smaller numbers of active and allocated. Call it that. I've also got a little trick that I've got up here, which will let me just solo this so I can run just one test at a time. Let's do that. Okay, so that's compiling and 23 actual. Oh. That's my fault. That's my fault because I've actually got the fleet specified at 100, which I don't want. All right, so I would like to be able to set this value, so let's do that work. Fleet spec replicas. And we're calling it 32. Here equals v dot fleet spec replicas. So we'll pass that in. We will need to make sure it's 100's a lovely number because it's evenly divisible by percentages. I'm trying to decide. No, I'll just reset. I'll just put it in here. Just put it in all the spaces that I want it to be. Here we go. Here we go. Here we go. And on this one, run it that way. And then we can just keep adding more fields. Cool, that looks good. All right, let's try that again. Compiling. Here we go. So it did break. That's right. There we go. Okay. Error controller test. Which one failed? So we expected it to say, hey, we should have 1, but we have 0. Interesting. Why is it 0? Let's have a look. We still have a bunch of debug stuff in here, so let's have a look. Rolling update deployment. Where is this logging coming from? A bunch of logging. Where's my message? Unavailable. Nope. Get value from enter %. Oh, there it is. Okay, you can go away. Here we go. I have a roundup of false. That's probably bad. That should probably always be true because if I get a value that's smaller than 1, then I'm always going to get 0, which means it'll never grow. Let's run that again. Nope. Nope. That's not the answer. Interesting. Okay. Then we need to step through this. All right. Should get 1 eventually. So let's step through this. This is where it gets to be hilarious fun. Oh, for small numbers, there's bugs in here. And I think I know why there's bugs in here. Okay. This should definitely be true to round up. So let's just do that. Yeah, because if I do really small values, actually, let's look at that real quick. Say I have 2 and I multiply that by 25%, I'm gonna get 0.5, and then if that rounds down, I'm never gonna get anything. So I always have to round up. Okay. By the same token, yeah, I will want to do that from here too. Because yeah, I always want to round up for both of these. Otherwise, if I ever try and subtract 2, that's bad. Okay, so there's that. Now, this is wrong. This is wrong. It's close, but it's not 100% right. Okay. Basically, what I've done here is, okay, let's just step through this so that I remember what I've done. So, okay, so I have max surge. So I grab, basically how much my surge should be is the percentage of, in this case percentage, it could actually be a flat number, which is fine, of the number of replicas. So 25% of the replicas. And I say my maximum surge could only be the surge plus the number of replicas. So that's like, I can't go over that number at any given point in time. I add the current number of replicas. What is that? Okay, which is the active spec replicas. plus the surge. I have an upper bound, which is basically saying don't ever go over a number of fleets. And then I sum the number of replicas from all the other game servers that may exist, and I add my set of the replicas, which gives me a total, which says, okay, so if I'm over the max surge, then make sure that I'm under the max surge. Oh my god, that's really fun. Basically work out the diff. Yeah, work out the difference between the max surge and my current total and subtract that from my replicas, because I have two numbers that I'm adding together and they're big. Square Pig, does UE4 work with Agones? So we have a C++ SDK, and we have an issue currently tracking for Unreal. No one's tried it yet. So we've been working with sort of proprietary game servers recently. It's a very pushed up. I would love for someone to come in and test out the C++ SDK and see if it works with UE4 and if there's anything that we need to change in there. That is something that we want to have happen. We just haven't got to it yet, basically. But yeah, if anyone's really keen to get in there and try and test and see if that SDK works, that would be sweet. That would make me super happy. Good question, though. All right, and then I grab the replicas, and I always subtract the allocated, but that's not right. And how I do this? Do I do this? I do this on replace, and I'm just looking at it here. And replace is fine because we're basically always going to, yeah, that's fine because we use the higher value. I do a very similar thing, but here, let me think this through for a sec. I think I need to do basically the same thing here again, which is to say that basically the way I want this to work, and it's kind of weird, but I want to allow the new game server set while it's rolling through while it's going through, I want it to be able to go to max surge. So like say 100 to 125, so we have 25% max surge. But once it's finished, I want it to leave a gap for allocated stuff. So say you had like 5 allocated, therefore, I'd say 5 allocated from the old ones. Therefore, once we come back to 100, there should be 95 in the new one and 5 of the old one left over. I don't want 100 of the new one and 5 so that you end up with this little surge. That feels really icky to me. I'm going to come back to a happy state. I will poke some of my buddies on the UE slackers. Awesome, please do. That would be great. Thank you, SquarePeg. So. Yeah, this gets complicated. I didn't think this was actually going to be this complicated, but apparently I was wrong. Yeah, it's this. So the funny thing is about this, that the game server stuff is really about dealing with game servers that have people playing on them. If we could just arbitrarily delete stuff like you can with across Kubernetes for stateless systems, that would be so much easier, but we can't. Okay, so let's think this through. Oh boy. Let me think this through. I feel like if replicas plus, all right, actually, let's give that a variable. We'll call it sum allocated. All right, perfect. Move that up. If replicas plus sum allocated was greater than fleet.spec.replicas, then do that. I feel like that will solve the problem, because then there's still room for things to grow in the bits, basically in that gap. So right now there's no room to grow, right? Like, because if you have 5, which is actually a really small number, which is why the bug shows up, you have 2 allocated out of that, you're always going to be deleting 2. and just weird stuff's going to happen, and it's not going to be good. Actually, where are we? Yeah, even then, that still should have given me one back. But anyway, let's just delete the fleet since we're here. Okay, so that, I think, will work better. Let's have a look at our test. Let's run it. See if we get anywhere close to what we should be getting. Not equal. We get 2 because we rounded up. So that's okay. So my test is just wrong. That's true. So we get 2 because we rounded up. Now we probably broke some tests, but that's okay. That's okay. So that should actually be 2 because we rounded up, and I would prefer to round up, so that's okay. Sweet. That now passes. This feels better. Let's kick this into here. So now that'll run all the tests. See whether we broke any. I wonder if there might be some rounding errors somewhere. Nope, that all passes. Good. Okay, that's actually really good. When I did this, I deliberately chose 100, so I wouldn't have to worry about rounding too much as a starting point. Oh, good question. I am, so just wondering, are you running Kubernetes locally? Cryptorge is the person who asked that question. And the answer to that question is yes, I am. I'm running Minikube locally. So where are we? Minikube status. So yeah, I am running Minikube right now just to run Kubernetes locally. I quite like it. I find it nice. I'm actually trying to do things now, whereas if I'm working on my laptop, I work on Minikube. I work for Google Cloud, so we have Google Kubernetes Engine. So if I'm working on my desktop at the office, then I try to use GKE, just so I get both experiences happening with the tool and making sure everything works across both. But yeah, Minikube's nice, and I really love the fact that, yeah, if I really mess things up, I can just delete my cluster like really fast and recreate it, which makes me super happy. So let's actually run go on ports. I think that will work. Let's just run the full controller test. Make sure nothing else is broken. Shouldn't be. Nothing else hits anything else there. Beautiful. Everything passes. Beautiful. Okay. Let's make build. Oh, actually, add -a, git commit. I think this fixes the bug with small numbers. I don't need to push that. I can push that later. Okay. All right, so that's going to take a little bit to run through. One of these days I'll solve that problem too, but it does take a little while to build. Okay, I think that will solve that problem now. So we just need to do the same thing all over again. Fun. Whew. How's that going? That is going to take a little while. All right, you can see, actually, as I was talking about that previously, you can see the new version with a new hash coming through there as that is building in the background. What can I tell you about things while we're doing it? So you were talking about, actually, Mr. Squarepeg, the... what is the difference between Kubernetes and Docker? Oh, that's an interesting question. So Kubernetes is, so Docker is a container runtime, is essentially what it is. It gives you a way of taking some software, putting it inside basically an artifact, in this case a container, that can then be transported around and started and stopped. Right? So in the first step here that we're actually building this thing here, we're actually compiling some code. We're then going to hear, this is actually doing some stuff to compile the code. We're then going to take that resultant binary. We're then going to put it inside a container. And if you actually want to see that, since we're working on this stuff, where are we? Docker file. So just a Docker file, we create this server binary. We copy it in. We set some permissions, and we set an entry point, which is to say, once you've created this container, then you can run it. So that's a container in a nutshell, right? So it's an artifact that'll have some common things for starting and stopping, right? Those are my common APIs. Docker is pretty much the primary production-ready container runtime right now. And so that's a container. Kubernetes itself is a system for running containers across a wide number of machines. So while you have this wonderful thing inside a container. It gives you this beautiful abstraction for like, hey, I need to start software, I need to stop software, I need to produce a new version and make sure I can distribute that to a bunch of people with security rules and verification and making sure it's the right thing and all that kind of stuff. What's lovely about that is then you can write these generic solutions for running software at scale because we have this abstraction, right? The conversation I like to have is like shipping containers, right? You don't care whether there's a Ferrari in there or like a bunch of tables or, you know, who knows what. At the end of the day, that shipping container can be picked up on the crane, put on a ship, taken from one place to another, and then picked up off another crane, put on a truck, right? Because of the abstraction of that shipping container, you can build these generic solutions for moving stuff around the world. Kubernetes is basically a generic solution for running software at scale across multiple machines, but doing it in a declarative and programmatic way. So Kubernetes is lovely in that it has extension mechanisms, so it enables us to build stuff like this. But at a very, very core level, it is just like, hey, I need to run 10, 20, 30 auto scale instances of this thing. Can you run those for me? Make sure there's health checking for me. If I need to do new updates, do rolling updates or potentially some kind of switch between the two. How do I expose this to the outside world? How do I take all my logs and aggregate it? If anything fails, how do I check those failures? And then if it fails, how do I restart to pick things back up again? Stuff like that. So all that kind of very generic stuff for running software. Kubernetes is kind of amazing in that really the code that we're building for Agones is just really just a layer on top of that. And there's so much stuff that we just do not care about, including things like, hey, I need an API to hit and I need security on that API so that I can manage my game servers. Well, I can create these things called custom resource controllers. Or custom resource definitions is what I'm doing here. Insert those into Kubernetes, and suddenly Kubernetes is like, oh, my standard API knows all about game servers now and fleets. That's cool. All my tooling still works, right? All that kubectl stuff, I didn't have to do anything magic for that. That's all the standard tooling for Kubernetes. It's kind of freaking awesome. All right. All right. So we don't have a fleet. We just dropped in a new version. All right. Let's retry our. Let's get logs. Where are we? I just like to do my eyeball check. I'm gonna sneeze. 1 sec. Oh, no, I'm not. Oh, yes, I am. Here we go. There we go. All right, Mrs. Squarepeg. So Docker and Kubernetes work together. Yes, exactly. So Kubernetes can actually work with multiple different container runtimes. There's Rocket, there's OCI. I'm probably messing those up. There's probably a couple other ones. None of those are really production ready, so Docker is the main one right now. But it's also got work for like Windows container runtimes as well. That's currently in beta, I want to say. Microsoft's doing some work on there too. So there's a few different container runtimes. Kubernetes is not Docker specific. But yeah, pretty much most people end up using Docker with Kubernetes right now. So no, you totally understand. That is exactly correct. Okay, so let's, all right, so we have this from before. Let's just create our fleet. We'll edit our fleet, bring it up to 5 replicas. Boom, lovely. How are we doing there? Cool. Actually, what I wanted was state. There we go. All right, sweet, we have 5. Let's allocate 2 like we did before. Whoop, whoop. All right, beautiful. So now we have 2 allocated. All right. Here comes the magic. All right, let's see. Let's see how we go. I kind of feel like I need a drum roll. All right, kubectl, edit, fleet, simple UDP. All right, we are gonna take this value, drop it down to say 4,000. Boom. All right, let's look at our pods. Ooh, interesting. All right, that looks like that's doing well. We have 2 being created, 3 being terminated. That's fine. 3 that are running. Let's grab state. Something's unhealthy. I don't know why it's unhealthy. That's weird. I wonder if I ran out of resources here. Ooh, one of these went really weird. I wonder. I think it'll go back to a natural state, but I'm actually wondering. So one thing that is kind of fun that I have run into before that I may be running into again just with surging, and I need to look at it, is you get 2 gigabytes of memory inside Minikube. And Kubernetes itself takes up at least about 1 gig of memory off the top of my head, something like that. And I'm not doing any resource allocation viewing right now. So if you hit that, like Minikube will start deleting pods. so and that's bad. So that's fair enough. But where are we? Grep container. If I look at container port, that's a good way of doing it. All right, so we're getting stuff coming through. Sweet, this is cool. If I look at state, it's kind of doing. So we have 4. Why do we have only 4? We should have 5, and we don't have 5. Why don't we have 5? I feel like there's a rounding error here somewhere. All right, let's have a look. So if we look at our older one, actually, bear with me one sec. Let's describe the fleet and see what happened. Okay, so I need some better. I need some scaling down events in here to see what's going on a little better. Okay, replicas is 5. We are very aware that we have 4. Oh, you know what it might be? It might be actually that if it goes, yeah, I think it will. Let's think this through. I think it'll try and it's thinking it's going to put itself over Surge if it adds an extra one. And that's what's going to be the problem. So that's okay. That's okay. That's fine. We can see we went from scaling active game server set from 4 to 5. Oh, that's weird. We have 4. All right, kubectl describe. Well, let's actually have a look at our get gs set. I want to look at the old one. Let's have a look. Okay, that should be down to. It should be scaled down to. Oh, it's scaled down to 1. Interesting. Okay, scaled down to. Really? Why is it scaled down to 1? I would have thought it would scale down to 0. But that's all right. That's actually fine because we still have 2 allocated, so whatever, we don't care. Oh, I wonder... Interesting. That's interesting. So it's scaled down to 1. All right, that's okay. I don't see that as a big problem. Sorry, let's get game server sets. So the one that's brand new, the one that's active is this one. So let's grab that. See what's happening there. What's that set to? That is set to replicas 2. Huh. So it's actually doing, it's saying it's doing what it thinks it should be doing, at least. I may not agree with what it's doing, but at least it's doing what it says it thinks it should be doing. All right, so here's a fun test. Let's delete one of the allocated game servers. Basically, so when the way the system works is it is assumed that when a dedicated game server comes to an end, it kills itself, right? It dies, it deletes itself, it shuts itself down. I'm still curious about that whole unhealthy thing. I wonder if it just overshot itself slightly and then brought itself back down. That's entirely possible. That does happen sometimes. I have seen it just kind of overshoot a little and then it goes, nope, that's too far, and then brings it back in. So that's interesting. That's interesting. I don't think there's anything inside. There we go. Let's source. Cube. Let's just give me that mini cube completion. I don't think there's anything that. I can never get that dashboard to work. I mean, I can have a look, but I don't think it works. I just want to see. I want to see if, will that work? Let's have a look. See if that dashboard will come up. It usually doesn't. Usually I end up putting something else in there. No. No. Yeah, I don't think it works. All right. Was worth a shot. I wanted to see if there was what the resource levels were at. Usually I install something else like WeaveScope or something like that. Let's have a look at the service list. It does say that there's a Kubernetes dashboard right here. Try that one more time. Oh, nope, it's up. Oh, cool. This is working. Let's have a look at our node and see. Oh, it's like fine. It's like totally fine. Oh my god. Okay, so all right, I think it must have overshot a little. Oh, this does work now. Ah, so nice. I wonder if it's still broken if I go to pods though. If I look at a pod, yeah, that breaks. Basically, for whatever reason, if you have a pod that's connected to any sort of custom resource definition, it just breaks. Breaks the whole dashboard. That's fine. All right, so we should have 4. That's what we want. So let's that's cool. All right, but that's good. What I wanted to see was just to make sure memory allocation limits. We have 170. Oh, we've asked for 160. There is not that much room. No, that is not true. I don't know if I believe that. Really? Really? All right, I'll have to take its word at it. I looked at some other stuff and I did not think it was that much space. I did not think it was that much space at all. Anyway, I digress. Okay. Brain function. What am I doing? Okay, so coming back to here, we want to delete one of these game servers. So let's come up here and we'll see. And then if that works, we might call it a day. Let's have a look. kubectl get yes. All right, so the older ones should be probably one of these. This is one of these is probably allocated. So let's have a look. kubectl describe. Oof. Let's just grab the state out because I don't want to read the whole page. GS. GS is game server. Okay, so that's ready. That's the so that's the newer one. I'm sorry. Let's grab this one then. All right, kubectl describe game server. Just get the state out. Allocated. All right, beautiful. Let's just delete that one. Let's delete it. Sweet. If we have a look at the backing pods, there's a pod behind a game server. One is being terminated. Lovely. Nothing should happen until that finally dies, which may take a minute or two. Come on. I want you to die. Out of curiosity, can we see anything here? Oh, at least it's doing that. That's in a terminated completed. All right, cool. No, still not 100%. That's interesting. What do we see? Yep. Okay, it's dying already. Oh, at least I get logs out of stuff. Oh, that's good. This is interesting. I haven't looked at the dashboard in quite a while. Oh, that's quite nice. We can actually see all the logs that are happening. So to your point about Kubernetes, we were talking about this before, Mrs. Krupik. This is like the nice stuff that Kubernetes just gives me out of the box without me having to actually do any work. And so that's kind of really nice. Sweet. All right. Oh, look. That one's pretty much dead. And now we're back to here. So now we have 5 again. Let's actually go container port. And that is looking pretty good. So now we're back to 4. Let's kill, what was the last one? Get pods. That's new. Whoops, sorry. kubectl get game servers. My fault. The oldest one is that one. I think that's the one that's the last. kubectl describe game server grep. What do I want? State. Cool. So let's delete that one too. And then we should end up with all of the new ones. Oh my god. Yeah, I thought this was actually going to be way easier to do first pass, but there are some tricky little edge cases in here that I did not pick up on. So I am pleasantly surprised that it's coming together. I'm just waiting for this to show up. Didn't I kill that? Oh, it's already gone. It's already like there's 5 of them. Oh, that deleted really quickly. Huh. Interesting. That's fine. So we only should have 1 game server set. We do. And if we describe the fleet, replicas 5, 5, 5. From 4 to 5. We actually scale that right here. You can see that line right there. Scaling active game server set from 4 to 5. Quick eyeball. Agones controller. See if any errors happened or anything that I'm missing in here. No, this is looking pretty sweet. Pretty sweet. All right. I think I might finish things up here. This has worked out pretty well. I'm actually pretty happy. You did ask a question, Mr. Square Pig. I'll bring it up just real quick. We were talking a little bit about issues. Where are we? Unreal. Yeah, here we go. So we had a whole discussion about it in here about like what was the right level of integration that should be done. As you can see, there's a lot of people who are like, yes, this would be lovely. I want this. And so there is a whole discussion about the right level of this. My knowledge of Unreal is very low. And so, whatchamacallit? There's a lot of good discussion from here from people who know more about this stuff than I do. Which is good. So if anyone needs some direction or they want to like try and dig into that, this is a great place to go. But yeah, this looks like this is kind of working. So I'm just going to push that while we're sitting here. Finally, I just want to say thank you very much to you all for hanging out with me. I think I'm going to get a couple more bits done on this today and hopefully get this in for a pull request today. I'm pretty excited. If you want to learn more about the project, there's links below. Agones.dev is the place to go, though. If you want to see me stream stuff more, you thought this was vaguely entertaining, I do a regular stream at 9 a.m. on Tuesdays, Pacific time, US Pacific time. Or you can just follow me on Twitter or here on Twitch. And I always put out a little note saying, hey, I'm going to do stuff either impromptuly or usually on the Tuesdays as well, assuming I'm not traveling or doing other fun stuff like that. But yeah, thank you very much to everyone for hanging out with me, and I hope you found this vaguely valuable, and hopefully we'll see some of you on Tuesday next week. Thanks so much.